Okay, hi everybody. Kind of a strange setup here, but today the lesson that we're going to be talking about is inverse square law. And, what does that mean? Well, light is energy, and this is basic physics 101. Sorry, more math and more science, but that's the way it is. And basically what inverse square law is that the energy emitting from a light source drops off or falls off at a very well-defined rate. We can actually get a tape measure out and a light meter out and measure it, and it will fall off the exact same amount anytime we do this experiment. So it becomes an essential understanding of light for a photographer to understand how light works, right? Because light has properties and it does not change. So that's the good thing. Once you understand how to use it correctly or understand how it works or how it behaves, right? Then we develop an understanding and a usage of that principle, that light falls off at a very prescribed rate. Now, what is that prescribed rate? Well, without drawing an equation and going through what the math is, I have another YouTube video that I'll put a link up for you to watch that does a really good job of this. But basically, we try to think of light as how much it dissipates or spreads out or falls off over distance, right? It's the reason you can't drive your car 100 miles an hour with the low beam headlights on, because you can't see because the light falls off, right? Think of a garden hose, right? The light falls off. So what do we need to understand about that for photography? Well, as we double the distance, so say we go from 2 feet to 4 feet, so we double the distance, right? You would think that light would fall off by half because we've doubled the distance. And you've heard me say lots of times that everything in photography as it relates to light is half or double. Well, not so fast here, okay? What happens is if we double the distance, 1 feet to 2 feet, 2 feet to 4 feet, right? We quarter the amount of light reaching the object. Not half, quarter, the inverse of the square. So 1/2 times 2 is 4, so quarter the amount of light. Does that kind of make sense? Okay. So you invert the fraction, 2 into 4. Okay, you get it. So you quarter the amount of light that reaches the object. So what I'm going to do here is a very simple experiment. I'm going to zoom in on the camera here in a second and get this a little tighter and get the exposure right. But all we're going to do is show you how light falls off. Now, what a lot of students make the mistake of, a lot of people get the difficulty of, is they think in order to get drama or get that great deep shadow on a subject that you need to move the light further away. No, the opposite is true. You need to move the light closer, and then you get that fall off very quickly, right? Light tends to fall off and then it kind of levels out. So as you move the light further away and get it really far away, it tends to level out and the exposure is a little more consistent. Now this can be an issue if you're lighting something from the front and you have a row, so 1 row, 2 row, 3 rows of objects, right? Let me grab another object. Let's say you had another object here behind it, right? And we're lighting it from the front. The light falls off, so that means this object's going to be getting less light. Now, it's not a big deal doing small products and things of that nature, but now think you're photographing a group of people. Let's say it's 20 or 30 people and you have them in rows. How much light are the people in the front going to get, and how much light are the people in the back going to get? There's your inverse square law, and there's your photography problem. Of what do you do, right? You try to light the people up more in the middle, or you back the lights off far enough that everybody is more evenly lit and you don't have that fall off. Remember I said the light falls off quickly and then it tends to level out. So you want to put the group of people in the level out area so that there's not a great difference from the person in the front row, the middle row, back row, far back row, that kind of thing. So there's your photography problem. using simple products like this, we can demonstrate this very easily, but in the real world situation, you have 2 or 3 people, even a family of 5 or 6, and you have distance between the people closer to the camera, further away, or closer to the light source and further away. The ones further away are going to receive less light. So not only do you have a depth of field problem with people in a row, or a family of, say, 5 or 6, and they're at different distances from the camera, but you also have an inverse square law or a lighting problem as well. So how do you handle those situations? Well, let's look at that, and we're going to do some experiments and some homework using window light. So something fun to do at home as well, okay? So let me zoom in on the camera and get this going, and we'll show you exactly how inverse square law works. Okay, so here's a little closer setup here. As you can see, and the exposure is better. And all I'm going to do is move the light on this side further away. And we'll see the light fall off, right? So I'm just going to pick this light up, and I'm going to roughly double that distance away. And now as we look at the object, you can clearly even see there's a deeper shadow on this side, right? Very little shadow because that light is much further away. And if we look on the front of this, you can see that it's much brighter on this side and much darker on this side. And all we did was move the light further away. Okay? So that's basically inverse square law. The further you move the light away from the subject, the lower amount of light reaches the subject, right? So we can use that to our advantage. Now, you don't have to get a tape measure out to do this, right? You don't have to get a tape measure out in order to make this work, right? I simply use my feet, right? Your step is pretty repeatable. When you take a step, it's pretty repeatable distance. So typically what I would do out in the field when I'm setting up my lights is simply take a step away, grab the light source, and move at that one step. One of the problems that I had routinely on location is getting this effect, right? Nobody likes to see a product evenly lit all the way around because it's boring. I took a lot of work from a lot of photographers because I understood doing this. Moving one light a little closer, moving another light a little further away, and you get some modeling or some light moving in and out or back and forth or upper and lower, however you want to look at it, in order to create some depth to the shadow and some more depth to the image, right? We're taking 3 dimensions and making them 2. Therefore, how do you persuade your viewer that height and width also has depth? This is one way of doing it, using inverse square law, using an understanding that light falls off and moving it further away or closer, depending upon what side of the object you want to favor or what side you want to light or how much drama you want to create. And create that look by simply moving the light. So the same thing works in effect here. Let me shut this light off. The same thing works in effect if we use a reflector on our subject, right? The closer we get the reflector to the light source, the more light we have on this far side. The further we get the reflector away, the more the light falls off. Right? Let's zoom in a little bit so you can see that a little bit clearer here. Again, so here you go. Move the reflector in close. You get a lot of light on the far side of the subject. Move the reflector further away and we get less light. Move it in, move it away. Inverse square law working with the reflector as well. So this is a really simple exercise in kind of how do we manipulate light and make it work for us to do what we want it to do. Very simple, okay? And I'll give you the details of the assignment in the next video, but basically we're just going to use some window light and use inverse square law. Okay? All right, see you in the next video.